All right, this is how you apply the impulse momentum theory. So here's impulse, here's impulse. J equals F times change in time. Momentum is P equals mv, mass times velocity. The impulse momentum theorem is impulse equals the change in momentum. So that means I can equal the equation for impulse, right here, to the equation for momentum, m times v. See that? So these two equations here are the exact same thing. Okay, these two equations are the same thing. All right, now, so this is what we're going to do. All right. So I'm going to take I'm going to underline my question here. It says an 8 Newton force. This is what you got to do. You got to underline force is F, applied to 12 kilogram mass. Mass is M for 12 seconds. So that's time T. What is we're going to do three things. Change in V. Okay. So when it asks what is the velocity, which equation do I have up here that has velocity? Okay. I have this one, and I have my impulse momentum equation. So look, I have to look at my letters, F, M, T, and V. So which one of these would be more appropriate? I don't have the momentum directly. I do have the force and the time. So let's go ahead and use this guy right here. Okay. So my force times my time equals my mass times my velocity. Which one am I solving for? This is what is the change in velocity. So I have to get velocity by itself. I divide by m to get rid of it because they're multiplying, right? And whatever I do to one side, I do to the other. So force times time divided by mass is my change in V. Is my change in V. Okay, so that's equal to, what's my force? 8 newtons times my time, 12 seconds. And my mass is 12. So what do I get? So this will just cancel out. 12 times 12 divided by 12. So I just get 8 meters per second. So that's my velocity. It's my velocity right here. But if you don't like that, let's do 8 times 12. Get 96 divided by 12 again, you get 8. Okay. What is the impulse if it's applied to the mass? So impulse is J equals question mark. So my equation for J is force times time. J equals force times time. And what's my force? 8. And what's my time? 12. So we did 8 times 12, 96. And of course, the unit for impulse, kilogram meters per second. And it's also the unit for momentum, right? And that brings us to this one. What's my momentum applied to the mass? Okay, remember, this is really important. Impulse is equal to the change in momentum. If I push a cart with a force times time, it's going to convert into a new mass times velocity that's equal to the original impulse. Okay? So impulse is equal to my change in momentum, right? The change in velocity of an object. Okay. All right. So I don't have to do any math. You might be tempted to go P equals mv. But you don't have to do that. You can, but you don't have to, because look, my impulse is equal to the change in momentum. Okay, so let's see, if I already had my impulse is 96 kilogram meters per second, guess what? My change in momentum is also 96 kilogram meters per second. But if you don't believe me, let's go ahead and do it. P equals mv. My mass is 12. And my v was, what do we get? 8, right? So what do we get? That's 96 again. So there you go. Okay, if you didn't finish the assignment for today, I need it. It's going to be a 0 until I get it. So finish this up. You use this for every single problem. Remember that if you have momentum, you automatically have the impulse, and vice versa. If you have impulse, you automatically have the momentum. That's the impulse momentum theorem. Okay, that's why the units are the same, because they have to be equal. All right, cool.